Okay, beta, now the topic is oxidizing property of hydrogen peroxide, that is the next chemical reaction, chemical property of H2O. Oxidizing property means hydrogen peroxide is going for reduction, therefore can oxidize other species. H2O2 when is converted to water and give nascent oxygen, H2O2 is giving us nascent oxygen. So -1 oxidation state is changing to -2. It means gain of 1 electron. There are 2 oxygen atoms, therefore gain of 2 electrons. Thus, self-reduction means oxidizing agent. Equivalent weight of H2O2 will be 34 by 2 is equal to 17. Now this reaction can be written in 2 types or 2 medium. One is an acidic medium and another is in reducing medium, alkaline medium. H2O2 going for reduction, give us water. Balance this reaction in acidic medium. And in alkaline medium, H2O2 plus 2 electron give us water and balance this reaction in alkaline medium. Try to balance the equation in both acidic as well as alkaline medium. In acidic medium, we can add H positive ions. It means H2O2 plus 2 electrons gives water. Here we have 2 hydrogen atoms, 2, 4 hydrogens. Oxygen is balanced, but hydrogen is not balanced. Therefore, 2 H positive ions to balance hydrogen. Peroxide plus 2 H positive give us 2 water. Balanced equation. But now we balance this equation in basic medium. Try to balance in basic medium. In basic medium, first we balance negative charge by adding 2 OH negative. Hydrogen 4, here hydrogen 2.
2 water.
It means water is to be added. Hydrogen 2 plus 2 4, 2 plus 2 4. Oxygen 1 plus 2 3, 2 plus 1 3. Right? Now water is added on both the sides, therefore water and water is cancelled out. It means overall reaction will become H2O2 plus 2 electrons. We get 2 OH negative, that is in alkaline medium. That is how we can show that hydrogen peroxide can act as oxidizing agent in both acidic as well as alkaline medium. Got it? Now, if it is oxidizing agent, we must know how to write the reactions in which oxidizing property of hydrogen peroxide is visible. For that we have, let us suppose first is hydrogen peroxide gives water plus nascent oxygen, and PBS is going to react with 4 nascent oxygens to give us PbSO4. Now hydrogen peroxide is multiplied with 4 so that we should get 4 nascent oxygens. And those 4 nascent oxygens are used here. Overall, the reaction is PBS plus 4 H2O2. We get PbSO4 plus 4 H2O. This reaction is a very important use of hydrogen peroxide because this black lead sulfide is converted to white lead sulfate. And this reaction is used for restoration of lead paintings. The lead paintings are getting black color on them due to exposure to sulfur or sulfides in air. And when we get PBS formation over there, we get blackening of lead paintings. And hydrogen peroxide solution, when is used to clean that painting, we get white color of the lead paint restored.
Lead is also white, normal lead.
Right? So this is how we can restore lead paintings, or restoration of lead paintings can be done. Nowadays lead paints are not used, but in traditional paintings, or we can say in historical monuments, when lead paints were used, so that restoration can be done by H2O2. Next is hydrogen peroxide can oxidize. If I write hydrogen peroxide can oxidize ferrous to ferric, that means you want to write ferrous combined with H2O2, we get ferric plus water. This reaction is done in acidic medium. As you have done redox reactions, you can balance this reaction in acidic medium. Balance this reaction in acidic medium. It is ferrous is converted to ferric, loss of 1 electron. Peroxide is converted to water, gain of 2 electrons. Cross multiply the number and balance the reaction. And medium here is acidic medium. Balanced. It will become 2 iron 2 positive plus 1 hydrogen peroxide, cross multiplying the number. We get 2 iron 3 positive plus H2O. Iron balanced, water oxygen balanced. Now oxygen can be balanced by adding water here and 2H positive on the other side. Iodide can be oxidized to I2. Iodide can be oxidized to I2. That means I negative plus hydrogen peroxide. We get I2 plus water. Again we can balance this reaction. Gain of 2 electrons. So loss of 2 electrons by iodide and gain of 2 electrons by hydrogen peroxide. It means 2 iodide plus 2 H2O2 gives I2 plus water. Now we can write it as 2H2O, hydrogen is balanced, oxygen, 4 oxygens are there, 2 oxygens are there, 2 2s are 4.
लॉस ऑफ 2 इलेक्ट्रॉन्स क्यों लिखा है?
ओहो,
1 इलेक्ट्रॉन आएगा ना?
लॉस ऑफ 1 इलेक्ट्रॉन, 51. तो balance. Now it is 2 hydrogen balance. Hydrogen peroxide is H2O2 oxygen. 1 oxygen is less. It is H2O oxygen balanced and 2 H positive. Now it is balanced. Right? Sodium arsenite. Na2ASO3 can be oxidized to Na2ASO4. It means hydrogen peroxide is converted to water and arsenates are converted to arsenites are converted to arsenates. Same way we can have oxidation of K4FeCN6 oxidized to K3FeCN6. So hydrogen peroxide can oxidize. Here iron is +2 and this iron is oxidized to +3. Main changes of iron. Rest of the elements are going to be same, cyanide same, potassium same. It is oxidation of ferrous to ferric again. So potassium ferrocyanide is converted to potassium ferricyanide. In hydrogen peroxide, acidic medium. So we can say potassium ferrocyanide can be oxidized to potassium ferricyanide.
ऊपर Na2ASO3
converted to Na2ASO4.
H2O2.
So hydrogen peroxide can oxidize potassium ferrocyanide to potassium ferricyanide. Clear? Next is due to oxidizing property,
ऊपर वाले का मीडियम क्या है?
neutral. Due to oxidizing property of hydrogen peroxide, H2O2 can act as an oxidizing bleach. It has oxidizing bleach acting nature. Reason for that is beta hydrogen peroxide when gives water plus nascent oxygen. This nascent oxygen combined with colored matter. Colored matter is going to react with oxygen and oxidize to colorless substance. That means colored things can be converted into colorless things just by having hydrogen peroxide mixed with it. The mixing H2O2 can decolorize the objects or things, and this is bleaching property of hydrogen peroxide. For example, ivory can be decolorized. Hair bleaching can be done. Wool can be bleached. Silk etc. can be bleached. So bleaching of ivory, hair, silk, wool can be done by using hydrogen peroxide. Hydrogen peroxide is an excellent antiseptic and germicidal. Reason is again same. It can oxidize all germs or bacteria, living beings, by giving nascent oxygen which can kill the organism. So we can say germicidal properties, antiseptic properties, all these are because of oxidizing nature. Next we have is reducing properties of hydrogen peroxide. Reducing properties of hydrogen peroxide are: hydrogen peroxide can gain one oxygen and is converted to water plus O2. It means as it can give nascent oxygen, it is oxidizing, it can take one nascent oxygen, it can become reducing. Here oxygen -1 is converted to oxygen 0. -1 to 0, it means loss of 1 electron into 2, loss of 2 electrons. Self-oxidation, therefore reducing agent. Equivalent weight, it will be 34 by 2, coming to be 17. And when we say reducing nature of hydrogen peroxide, it means we must know that reducing nature can be balanced in acidic as well as in basic medium. Hydrogen peroxide converted to oxygen with the gain of 2 electrons balance this reaction in acidic medium. And same way hydrogen peroxide gain of 2 electrons balance this reaction in basic medium. H2O2 can act as reducing agent also. Done?
No.
In acidic medium, hydrogen can be balanced by adding H positive ion. Balanced. In basic medium, it can be balanced by adding OH negative ion. Right? There is hydrogen peroxide going for oxidation therefore acting as a reducing agent. The hydrogen peroxide is giving us O2 plus 2H positive plus 2 electrons. In basic medium, it is hydrogen peroxide converted to oxygen. It means during oxidizing and reducing behavior, the product formed is different. If hydrogen peroxide is producing oxygen, in that case it is acting as a reducing agent, and if it is producing water, it is acting as a oxidizing agent. When we see oxidizing properties and reducing properties, the reducing agent means it can reduce few species. Example for reduction. First is MnO4 negative is converted to manganese 2 positive by using hydrogen peroxide. First important reduction is MnO4, which is pink in color. It is reduced to manganese 2 positive, which is colorless, by hydrogen peroxide, and this can be used as a test for hydrogen peroxide. We can write this reaction as, complete reaction can be written as MnO4 negative plus hydrogen peroxide. We get manganese 2 positive plus oxygen. And balancing can be done in acidic medium. H positive is the medium provided over there. It will become manganese plus 7 to plus 2, 5 electrons. Hydrogen peroxide is changing by 2 electrons. Gain of 5 electrons, loss of 2 electrons. Cross multiplication is there, 2 MnO4 negative plus 5 hydrogen peroxide. We get Mn2 positive, which is balanced as 2 Mn2 positive, plus oxygen. Oxygen can be balanced as 5 2s are 10, 5 oxygen, and water. 4 oxygen atoms are there, 4 2s are 8, therefore 8 water to be added. Eight H positive ions. Right? 2 manganese balanced, oxygen 4 2s are 8, 5 2s are 10, 8 oxygen balanced, hydrogen 5 2s are 10 plus 8, 18, no.
5 2s are
8 2s are 16, 5 2s are 10 plus 6, 16. Now it's balanced. Now this reaction can be written in the form of KMnO4. Write down 2 will make it 2 KMnO4. Combine with 5 H2O2, giving us 2 manganese 2 positive plus 5 O2 plus 8 H2O and 6 H positive ion. Now beta 6 H positive means 3 sulfuric acid. If I write 3 moles of sulfuric acid, here will be sulfate ion which is going to balance this manganese, and 1 sulfate will be giving us K2SO4. If I write this reaction as 2 KMnO4 plus 5 hydrogen peroxide plus 3 sulfuric acid, final products will be 2 MnSO4 plus K2SO4 plus 5 O2 plus 8 H2O. This is the overall reaction if we balance the charge of MnO4 negative with K, and H positive ions are provided by sulfuric acid. Second we can have is potassium dichromate K2Cr2O7 can be reduced to Cr3 positive by hydrogen peroxide. It means now we have to balance the reaction, that is dichromate ion in presence of hydrogen peroxide is converted to chromium 3 positive plus oxygen. Change in chromium is by 6 electrons. Change in peroxide is by 2 electrons, loss of 2 and gain of 6. Cross multiply the number, we get 2 dichromate plus 6 hydrogen peroxide. This number can be taken in a ratio 1:3. So we can say it is Cr2O72 negative combined with 3 hydrogen peroxide give us chromium 3 positive plus oxygen. Balance this reaction, 2 chromium balanced. Hydrogen, we can't balance right now, 3 2s are 6 oxygen. 3 2s are 6 oxygen. Hydrogen atoms can be balanced by adding H positive. 3 2s are 6 H2O. Oxygen is not balanced. That is right here. Balance the equation. Check the reaction. Is it balanced now? So this is about the second reduction process. Dichromate can be converted to chromium sulfate. Third is chlorine gas can be converted to chloride. It means it can reduce chlorine to chloride. Cl2 can be converted to Cl negative. 0 to -1. Gain of 1 electron into 2, that is 2 electrons because there are 2 chlorine atoms. So hydrogen peroxide can be used to convert chlorine gas to chloride ions. Right? Now you can balance this reaction by your own. Next is chlorine can be converted to chloride. Similarly, Ag2, silver oxide, can be converted to silver. Ag1 positive can be converted to 0 now. It is Ag2 plus hydrogen peroxide. We get 2 silver plus oxygen plus water.
acidic medium में
Neutral. Right? So all these reactions are reactions in which hydrogen peroxide is going to act as a reducing agent. Now K3FeCN6 can be reduced to K4FeCN6. Now this is possible in basic medium. That means in basic medium we can go for the ferri to ferrocyanide, but in acidic medium it will be reverse is true. That means this reaction can attain equilibrium. It's a reversible reaction. इससे पहले आपने किया था K4FeCN6 can be oxidized to K3FeCN6 in hydrogen peroxide presence. Acidic medium. Now I am saying that K3FeCN6 can be converted to K4FeCN6 in presence of basic medium. So in acidic medium, ferro to ferri is converted possible, and basic medium ferri to ferro is possible. Ozone can give O2 plus nascent oxygen. and hydrogen peroxide can absorb this nascent oxygen, we can get water plus oxygen. It means ozone is a powerful oxidizing agent as compared to hydrogen peroxide. That's all about your reducing properties, reducing agent nature of H2O2. Hydrogen peroxide is again famous for some important addition reactions around double bond. The addition reaction shown by hydrogen peroxide is carbon double bond carbon, if is there and hydrogen peroxide is added to it, we get formation of glycol. So hydrogen peroxide can be added to alkenes leading to the formation of glycol. That's all about your chemical properties of hydrogen peroxide we are finished with. Now there are important tests for checking the presence of hydrogen peroxide. Tests for checking presence of hydrogen peroxide. First test we have done already, KMnO4 test. Reaction you have done, KMnO4 pink to colorless. Hydrogen peroxide can make it Mn2 positive, which is colorless. Second test we have is titanium sulfate test. Titanium sulfate, when mixed with hydrogen peroxide, we get a yellow precipitate formed. So yellow precipitates are formed for a complex that is H2TiO4. Titanium here is 4 positive and this complex is having 2 positive. And titanium is now having a complex form which is colored by nature. So we can say this complex is having yellow color, and this test is again used for testing the presence of H2O2. Next is potassium dichromate test. Third test for H2O2 is potassium dichromate test. Potassium dichromate test is potassium dichromate mixed with sulfuric acid and hydrogen peroxide in presence of ether. Cold mixture is there, cold solution is there, and we get formation of a compound called chromium pentoxide plus KHSO4 plus water. This chromium pentoxide, because concentrated sulfuric acid is used, therefore KHSO4 is formed. If dilute sulfuric acid is here, we get K2SO4. Now, this CrO5 is having a butterfly-like structure, that is chromium pentoxide having 2 peroxide linkages, and this is having blue color. So we get blue colored solution of chromium pentoxide. This chromium pentoxide, when is heated with sulfuric acid further, we get formation of chromium sulfate plus water, and this chromium sulfate is green in color. So potassium dichromate can be used for testing the presence of hydrogen peroxide, and in this test we are having first blue color in the ether layer, and then later on heating we get green coloration. That's about your testing the presence of H2O2. The last topic for hydrogen peroxide is structure of hydrogen peroxide. The hydrogen peroxide is having half open book-like structure. Its structure is half open book-like structure. This angle of the book between the two pages of book is called dihedral angle. This angle between OOH bond is theta. Bond length here, OH bond, there it is one bond called OH bond, another is OO bond. Right? Okay. It means when we talk about hydrogen peroxide, it's structure like half open book-like structure. One oxygen and another oxygen, these are on the, you can say this binding of book. One hydrogen on this page, another hydrogen is on this page. Hydrogen and hydrogen. Now bond angle, this is dihedral angle, not bond angle, because one bond is of one oxygen. This bond is here and this bond is here. Bond angle is between the bonds on the same atom. This is bond angle, but this is not bond angle. This is dihedral angle. Dihedral angle is angle between the two bonds on two different atoms. Right? Now this angle, dihedral angle, now you must remember that in solid phase and in gas phase, solid phase and in gas phase, this angle is going to vary. In gas phase, this bond angle is going to be 111.5 degree, while in solid phase, this is 90.2 degree. Now you can imagine that bond angle, dihedral angle is going to change a lot. Why in solid phase this angle is changed? Because of extent of hydrogen bonding. Because of extent of hydrogen bonding, we have change in the bond angle from 111.5 degree dihedral angle to 90.2 degree dihedral angle. That means this angle of the book is going to change. In gas phase it is different, in solid phase it is different. Even the bond length is going to vary. When we say OO bond, in gas phase it is 147.5 picometer. That is OO bond value, and 145.8 picometer. This is oxygen bond length. The bond length of O and O is going to vary again. Same way, we are having OH bond. OH bond in gaseous phase, it is going to be 95 picometer. But this OH bond is 98.8 picometer in your solid phase. And theta, that is bond angle, in gas phase this bond angle is going to be 94.5 degree. And solid phase it is 101.9 degree. That is theta. The two structures are going to vary, differ, just because of hydrogen bonding. Extent of hydrogen bonding in two structures, two phases is going to be different. That's about your hydrogen peroxide. But a hydrogen peroxide, if we have 30% hydrogen peroxide, commercial name of 30% H2O2 is perhydrol. And this perhydrol is important antiseptic mixture which is used in antiseptic medicinal properties, used for antiseptic medicinal properties and germicidal, that is called perhydrol. Hydrogen peroxide is a good rocket fuel supporter. For rocket launch, oxidizing agent used is generally a hydrogen peroxide. because it can provide very fast nascent oxygen. That's all about your hydrogen peroxide and its chemical properties. We are finished with the topic hydrogen peroxide. That's all for today's lecture. Thank you, beta. Thanks for the class.